cloud. For everyone that just joined, I'm kind of going over something that you may need to know. So then since the top 5% qualifier for the academy, the area to the right of this z-score would be 0.05. And then you can find the area to the left by just taking 1 minus the area to the right. And that area is 0.95. Then you just need to find a z-score such that the probability of getting a z less than or equal to this z naught is equal to 0.95. So what happens if I change this number? If the percentage that qualifies, say I want the top 4%, then how would that change this right here?
Wouldn't that just make it 0.04 over there?
Yeah, and then what would be on the left?
Would be 1 minus 0.4.
Yeah, so then it just changes that way. Then you would be looking for a z-score such that the probability of z being less than it is 1 minus 0.04, which is 0.96.
Yeah.
Then all you need to do is find this area inside the z-score table and find the associated z-score with it. Where the heck did I put my tables?
Which would be
There's actually 2 of them that I would take.
says 90%, 95% of all values within 2 standard deviation of the mean.
So that one is if we have 2 tails. In this case, we're doing just one side of it. In that case, it'll be a little bit different.
It says is this more what I'm looking at? Like if z falls below the mean?
No, you'll look at, this is kind of similar to in the practice exam that I was telling you all about the other day. What number is it? I think it's 11 or 13 or 14. It tells you the area that it wants. Then you have to find the associated z-score. I'll show you how to do it once I find these tables. Where the frick did I put them? Gosh dang it. Here they are. Then what I'm saying you need to do is look in the middle right here. So these are the areas to the left of z-scores. Those are the probabilities associated with them. I'm saying,
0.5.
what's up?
Top number be 0.5 up there.
No, in this case, you're looking at, so this is the z-scores corresponding to these areas. So say I have like a z-score of 0.12. That means the area to the left of that z-score is 0.5478. In this case, I'm telling you the area to the left of some z-score. So I'm telling you the area on the inside here, and I want you to find the associated z-score by intersecting those 2 rows where you get that number. Does that make sense?
Yes.
So for instance, I have 0.9495 here and 0.9505 here. So that's the closest I can get to 0.95, right?
Yeah.
Then those 2 associated z-scores are 1.64. So do the 1.6 and then the 0.04 or 1.65. In this case, we're actually going to use this one. We will understand why that is next chapter.
Is that 0.9505 right there?
Yeah, 0.9505. And actually, if you look at your T distribution table too as well, if you look at the z-score down here at the bottom with 95 or 90% confidence, which is what this is in this case, it's 1.645. And if you round that 4 up, it goes to 1.65.
So you would take either one of those?
Yeah. So when if I write up the key, it would say something like, if it's in between these 2, I would let you use either or. But in this case, I'm just going to use 1.65. So that means this z-score here is 1.65, and that's corresponding to the top 5%. Then I want to use the formula of z is equal to some data value of interest minus the mean divided by the standard deviation. And I want to find this value here. This will be the minimum score I need, the x value of interest. So the z-score is 1.65. This data value of interest, x, is what we're looking for. I tell you the mean, which is 490. It's up there. Now I tell you the standard deviation, which is 30. Then all you do is solve for that data value x. To do that, multiply both sides by 30. And that'll get rid of the 30. And then you add over the 490. So then x would be 1.65 times 30 plus 490.
I can't do that off the top of my head, but.
Oh, I can't either. I'm doing it on a calculator. Should be like 640. Nope, I'm stupid. 539.5 is what it is. And if I put something like this on the exam, it would say either round to the next whole number or leave as it is. But in most cases, we round to the next whole number. So the minimum score needed is 5. So 39.5, that rounds up to 40. So 540. Does that make sense how I did that, everyone?
Yes.
All the other three, are y'all okay with that? Okay. Then there was also a question that asked you to find the standard deviation. So in this case, you know the z-score, you know the data value and the mean, but you have to find the standard deviation. That one's a little bit more tricky. And I won't go over that. Another thing I think you should know is, say, if you're in the bottom, so the bottom 3%, say, have to repeat the current grade they're in. Then B, find the minimum score so that you don't have to be held back. Could you go over question 17? Yes, I can go over that, Elizabeth.
I'm gonna watch you go over this right here, and then I gotta get back to this lab.
All right, sounds good. This is everything else I told you yesterday. If
And
you have that written down and in examples, you should be fine.
okay, I have that. I'll watch this and then I'll bounce. Or is this one that we went over yesterday?
This is not one we went over yesterday. I went over the first part yesterday, but not the second. Then the top 3% would be down here, right? The bottom 3% means only 3% or less than that. So the area to the left of some z-score is 0.03. And this is the unknown z-score, z naught. Then you need to look for a z-score with 0.03 area to the left. And if you do that, let's see what it is. The closest to 0.03, where the frick is it? Here we are, we'll just use this one, 0.0301 minus 1.88. So Z naught is minus 1.88. Then we do the same idea we did in this part. We have the z-score of interest, we know the mean, and we know the standard deviation, so we can find the associated data value of interest. So just set that up and you have minus 1.88 equals the data value you're looking at, which is the minimum score, minus the mean of 490 divided by the standard deviation of 30. And then again, you solve for x by multiplying by 30 on both sides and then adding 490. If you do that, it's minus 1.88 times 30 plus 490, and I have no idea what that is. Look, let me type it in real quick. Minus 1.88 times 30 plus 490. 433.6. In this case, you want to round that up again. So the minimum score.
434.
Yeah, 434.
That's pretty similar to the one we just did.
Yeah.
Except different.
Yeah, it's just, in this case, I tell you the area to the left already, but in this one, I told you the area to the right.
Okay.
So you just had to find the area to the left. So it's basically the same idea. Does that make sense, everyone?
Yeah, that's good for me. I'll add this couple things we went over to my note card, and I should be good.
Yep.
All right. Thank you, sir. I appreciate it.
You're welcome. See you tomorrow.
See you.
Okay, everyone else, I'll still be on here. Are there any particular ones you want me to look at from any of the practice exams? Are there any ideas you're confused about besides the one person that mentioned number 17 on one of the practice exams? Okay, let's look at number 17, then let me find the practice exam. Dang it. There. Okay, I'm just going to share the screen because I need to find it first. Can y'all hear my background music or the TV? Okay, good. The Office is on in the background. Okay. Here. Let's do this one right here. Sure. Y'all can see my desktop now, can't you? Why in the world is it not letting me enlarge this? Stupid thing. I'm just going to scroll down to it. Is this the one you're talking about? Okay. Then let's look at this. So do you know how to find the sample mean and the sample standard deviation just on your calculator? Because you'll need that. Okay. Then to find the z-score, or not the z-score, it's a t in this case because we have sample data. So the confidence level in this case is 95% confidence. And the sample size is however many data values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 11? Yeah, so N is 11. And on the T distribution table, you need the degree of sorry, you can't even see my paper. You need the degree of confidence and the degrees of freedom. And the degrees of freedom can be found by the sample size minus 1. And N in this case is 11. So the degrees of freedom is 10. Then you just intersect what does it say on the top? I'm looking through your distribution table to see what exactly it says. You intersect confidence intervals that's not how you spell intervals. And in this case, we're looking at 95%. Will we bring they will be on the exam already, actually. They're on the back. So you intersect the 95% confidence intervals with 10 degrees of freedom. And if you do that, here's the little table thing. So you just go 95% confidence intervals right here. And then you go down to 10 degrees of freedom and you intersect those two to get 2.228. So that implies T alpha over 2 equals 2 point, whatever I just said, 228. Does that make sense, Elizabeth? Okay, cool. And then once you have this critical T value, you already found the sample mean and sample standard deviation on your calculator, then you can find the confidence interval. Just make sure you know how to identify each part of it, because it will be like that on the exam. Everyone okay with that part? Is there any other thing y'all want to look at? Does everyone remember how to find the associated areas or the probabilities on the Z-score tables? Because you'll probably need to know how to do that. Yeah, and go over it. So say for instance, you'll have something like this. I would give you the probability of Z being less than some Z score. So let's say 1.25. And in this case, it would say, draw the graph and shade the appropriate region and then give me the probability based on that. And if I do that, say I have the distribution of the Z scores here. And I want the probability of getting a Z score less than 1.25. So remember that the Z distribution distributed normal with a mean of 0 and a variance of 1. So we can say that 1.25 is probably right around here. And then what area are we interested in this case? The area to the left or the area to the right? Yes, the left is correct. So we're looking at the probability of z being less than this. So that's the area over here to the left. And then the table already gives you the area to the left. So all you need to do is look at the z-score of 1.25 and look at the area to the left of that. And if you do that, in that case, you just go into here to 1.2, intersect that with the 0.05 to get 0.8944. How do we know that we shade the area to the left? In this case, we're looking at the probability of getting a z-score less than something, and the z-scores less than this right here is going to be the z-scores to the left. Does that make sense, Callie? Okay. And in this case, so we said this probability, which you found in the can find in the table, is, so you do 1.2 on the left, and then intersect it with that 0.05 on the top, and that gets you 0.8944. Then what would it be if I said find the probability of z being greater than 1.25? Which area would that be? So I guess I'll shade it in green. It would be the area up here in green. This part right here. Can you see that in the green? Then to find the area in the green, all you do is take 1 minus the area to the left. So 1 minus the probability of z being less than or equal to 1.25. And in that case, we already found it. So it's just equal to 1 minus 0.8944. And that is equal to 0.1056, I think. Everyone understand how I did those two parts? Now, you should also probably know how to find the area in between two z-scores. So the probability of, say, we have negative 2.13 to 1.34. Then if we draw out the area we're interested in, so say here again, you have the distribution of the z-scores. Again, you have the mean of 0 right here in the middle of the bump, and we're looking at negative 2.13, so that's probably around here somewhere. And your drawings don't have to be exact. So there's negative 2.13, and there is 1.34 is probably like right here. And which area do we want? We want the area in the left, the middle, or the right. What do you think? Yeah, the middle. In this case, I'm saying find the probability of getting a z-score in between these two. So since it's in between, I want this middle area here. And the easiest way to remember how to find this is to look at the probability of z being less than the higher z-score. And that will give you all the area to the left of 1.34. So we have probability of Z being less than 1.34. But we only want the area up to minus 2.13. So we need to subtract off the area to the left of that, which is just the probability of Z being less than minus 2.13. And both of these areas can be found on the table. And if I do that, I have no idea what they are because I just made this up. So I said 1.34. So we go 1.3 over to 0.04. That's 0.9099. Then the area to the left of minus 2.13. You go minus 2.1 over here and then up to 0.03, 0.0166. And if you do that, I have no idea what that is. So let's figure that out. 0.900, oops, 9099. 0.8933. Everyone okay with how I did that by looking at the area in the middle? Do you want me to go over how to find the Z-score if I give you the area already? Let's look at an example real quick. I'll just make one up. Say I tell you the probability of Z being greater than some Z-score, say greater than or equal to, is 0.9864. 0.9864. Then I want you to find this associated Z naught in that case. So the idea is kind of the same. You want to draw the Z curve. You want to shade the region that I'm telling you. In this case, I'm saying the probability of Z being greater than some Z score is 0.8964. That means the area to the right of some Z score is 0.8964. So it's probably around here. Z naught and the area to the right of this is 0.9864. But your standard normal table only gives you the area to the left. So how do I find the area to the left of this Z-score here? So using the same idea as earlier, we take the probability of Z being less than Z naught is equal to 1 minus the probability of Z being greater than or equal to Z naught. I tell you this area already is 0.8964. So it's just 1 minus 0.864 is the area to the left of that. So that would imply that is 0.0136. Everyone okay with how I got that? Just taking 1 minus it because the total area under that curve has to be 1. Then I just look for a z-score in the table with this area to the left. So in this case, you are given the area, so you need to look for the corresponding z-score on this by looking inside here, which gives you the areas to the left already. So I said it's 0.0136, and that's right here, negative 2.21. So in that case, our z naught would be minus 2.21. Everyone okay with that? Okay, cool. Is there any other thing y'all want to go over? Some of the word problems are confusing to me. Which ones in particular, Sage? Interpreting some of them is quite difficult in some cases. There's one question on your practice exam that is 15A and B. Is that the one where you have to use the binomial table? I think it is. Let me do something real quick. Oh, 15A and B. So I can go over that real quick. That's just using kind of what we just talked about. I'm going to print this page off real quick so I can show you how to do it. Sorry, one more printer's taking forever. Quit. Welcome, Elizabeth. See you tomorrow. Yes, I can go over how to do the binomial table as well, Sage. I'll print that page off as well. Let's do this page 16 as well. Oh, that's on page 16. What page is it? Here's number 16 or number 15. It says the average electric bill in Stillwater, Oklahoma is $67. The standard deviation is $9. If the amount of the electric bills are normally distributed, find the probability. In this case, the way it kind of hints at you need to use these to convert them to z-scores is this part right here, normally distributed. If I tell you something is normally distributed, it's kind of a hint that you need to use the z-scores to find the associated probabilities, because you can transform these data values into z-scores based on the formula. the easiest way to do this is to write out what you actually want. It says find the probability of a single electricity bill being over 80 bucks. So we want the probability of X being greater than 80. You don't have to write dollars there. Do you want me to draw out like what it's representing in this case too? The area it's representing. It helps some people if they do. Then here I have the corresponding distribution of, say, the electricity bills, and it's normal. And in the mean here we have 67. And we want the probability of getting an electric bill greater than 80 bucks. So say 80 is right here. We want the area to the right of that. Everyone okay with that part so far? Then in this case, we can just find that by taking 1 minus the area to the left of it. So the probability of X being less than or equal to 80. Then we want to convert this data value of interest 80 into a z-score using this. Z is equal to X minus mu over sigma. In this case, the data value we're looking at is 80, so that's our X, minus the mean, which is 67, over the standard deviation of 9. And if you do that, you get 13 over 9, which I don't know what that is. 1.44 to 2 decimal places. So that means the probability of X being less than or equal to 80 is the same as the probability of getting a z-score less than or equal to 1.44. Do you get why that is? I just transform this data value at 80 into a z-score using the z-score formula. And then you can find this area here in the standard normal table. And if you do that, the probability of z being less than 1.44, all you do is look at 1.4, intersect it with 0.04, that's 0.9251. So it's 1 minus 0.9251, which gives you 0.0749, I think. Let me check. 1 minus 0.92. Yep, 0.0749. And that would be your answer. Did y'all see how I figured that out? This next one is a little bit trickier. In this first part, it just says find the probability of getting a single electric bill less than being over this amount. In the second part, it says find the probability that the sample mean from 10 electric bills will be between 60 and 75. In that case, we're looking at the probability of a sample mean being in between 60 and 75. So we're looking at the probability of 60 being less than X bar, being less than 75. Now, in this case, the distribution of the sample means is going to be something a little bit different. It'll have a different parameter value. So in this first part, we had that the electricity bills, they were distributed normally with some mean 67 and some standard deviation 9. In the second part here, we're looking at the distribution of X bar. So the sample means are distributed normal because our original variable is distributed normally with the same mean of 67, but a standard deviation of 9 divided by the square root of the sample size, which in this case we sampled 10 electric bills, so n is 10. So we 9 over the square root of 10 as the standard deviation. Do you want me to explain why this changes? Then if we have that the sample means are distributed normal with this mean and this standard deviation, I can find the corresponding z-scores to each of these using this idea. So then the z-score corresponding to 75, I'll call it z1, is equal to take the sample mean we're interested in that case, subtract off the overall mean and divide by the standard deviation. In this case, the first sample mean we're looking at is 75. I subtract off the overall mean of 67. And I divide by the standard deviation of 9 over the square root of 10. And if I do that, that'll give me the z-score corresponding to 75. If I do that, that is it is equal to 2.81. Then using the same idea, you can find the z-score corresponding to 60 by taking the sample mean of interest, which is 60, subtracting off the overall mean of 67, and divided by the standard deviation 9 over the square root of 10. If you do that, that is negative 2.46. Then the probability of this right here, getting a sample mean in between 60 and 75, is the same as the probability of getting a z-score between minus 2.46 and 2.81. Everyone okay up to there? Then you can do this same thing by taking the probability of z being less than the upper one, probability of z being less than or equal to 2.81, and subtract off the probability of z being less than or equal to negative 2.46. Yeah, it all goes back to the curve and the z-scores. It's just in this case, the distribution of the sample mean slightly changes, but the idea is still the same. I take the value of interest, I subtract off the mean, and I divide by the corresponding standard deviation to convert it into a z-score. It's just in this case, the distribution of the sample means has a different standard deviation. So this denominator here is different. Then this is equal to whatever it is. If you look it up on the solution key, I can't remember what it is. Stat 2013. What the heck is it here? If I do this, the first one, the probability of z being less than 2.81 is 0.99. 0.75. And the probability of z being less than the lower one, negative 2.46 is 0.00. Gosh dang it. 0.0069. And that gives you 0.9906. And that is the answer. There any other questions over that one? Okay. Now let's look at that other one we were talking about earlier that involves the binomial table. In this case, it says an upper division statistics class has 12 students. Assume that all students are independent of one another, and there is a 75% attendance rate for that class. What is the probability that at least 10 students will be in class? In this case, you need to know actually that this is a binomial experiment. So to do that, you need to actually notice that first, there's a set number of trials. In this case, there's 12 students. So there's a set number of trials. The probability of success remains constant. So that just means the probability of attendance is the same for every person, and it's 75%. The trials are independent of one another because each student's, whether they show up to class, is independent of the other. And obviously there are only two possible outcomes. Either they come to class or they don't. So therefore it's a binomial experiment. So we can use the binomial table to find the associated probabilities. Is everyone okay with that so far? Then the first thing you want to identify is the number of trials. In this case, we had 12 students, so the number of trials is just equal to 12. The probability of success is the probability that they show up to class, which is 0.75 or 75%. Then the first part, it says, what is the probability that at least 10 students will be in class? That means we want the probability of X being greater than or equal to 10, where X is the number of people who show up to class. Then what possible values can X take on? Either it can be 10, 11, or all the way up to the total number of students, which is 12. And since this is a discrete random variable, we want to take the probability of each of these and add them up. Everyone okay with that? Then what you need to do is look for these probabilities in the binomial table. So in the binomial table, it has n, p, and it has a little x. In this case, the little x is these values here that we're trying to figure out if it's equal to. And we want to find the probabilities associated with those. So let's look at it. What is the number 12? So we had the number of trials was 12. So n, this far left-hand side is 12. The probability of success is 0.75. So all you do is go over here to 0.75, go down to 12, and look at the probability of 10, which is 0.23. Gosh dang it, I go farther down. Right here, 0.232. So it's this one right here. The probability that X is 11 is this one right below it, 0.127. And the probability that X is 12 is that one right there, the very bottom one of 0.032. So you just take these three probabilities and add them together. So let's do that. So it's 0.232. 0.1. there. Then if you add all those three up, you should get, let's see. .391. 0.391, and that is the final probability. You want to everyone okay with that one? Now the next part, what is the probability that 3 students will be absent? This one is a little bit different because in this case, the first part says, what is the probability that at least 3 of them will be in class? So the P we were looking at was the probability that they come to class. In this case, we want to look at the probability that they're absent. So the probability that they're absent is just 1 minus the probability that they show up to class, or 1 minus 0.75, which is 0.25. So in this case, we're looking at P is 0.25. Does that make sense? And we want to know, what is the probability of X being just 3? It says, what is the probability that 3 students will be absent? So we're just interested in the probability that X is 3. Then you intersect 12, 3, and 0.25, and you get 0.258. Everyone okay with that? And then the last part, if you assumed an elementary statistics class with 86 students had the same attendance rate, so in this case, the attendance rate that we're interested in is just 75% again. So P is 0.75. How many students would you expect to attend class? That means we're looking at the expectation in this case. So we're looking at the mean of the binomial random variable. And remember that the mean of the expectation is equal to the number of trials times the probability of success for a binomial random variable. The number of trials in this case is the number of students, or 86. And the probability of success is the probability that they show up to class, which was 0.75. And if you do that, you end up with 64.5. So round up to 65 students. And that is the answer. Everyone okay with those? Are there any other parts of the practice exam you want me to go over? Okay, well, if there's no questions from me, y'all can go ahead and leave, or you're free to stay. I'll be on here for a little longer. You're welcome. Can you do a problem with the steps from chapter 7? Yes, I can. So let me look at one real quick. Where the heck? I must have put them somewhere again. So let me print off one of the examples that I put on one of the practice exams, and I'll show you how to do it. Elementary statistics. Where was the one that I gave last year? page is it? 7. Current page. Print. Okay, here's one that we can look at. This has all the steps that I usually go by. Can you see this, Callie? It says if we take a random sample of 20 students at OSU and find their average GPA is 2.51 with a sample standard deviation of 0.4, we want to create a 99% confidence interval for the population mean GPA of OSU students. So this first part just says find the sample mean. So we're identifying the point estimate. And in this case, that's just simple. We just read off what the average GPA for the sample was, and it was 2.51. So this first part is just 2.51. Then the next part, find the critical value. In this case, I give you the sample standard deviation. So what critical value do you need to use, a Z or a T? So if we only know the sample standard deviation, we need to use a critical T. So we need to look at a critical T value with 99% confidence and a certain number of degrees of freedom, which is equal to n-1. And our sample size was 20, so the degrees of freedom is 19. So then I just want to look in that T distribution table for 99% confidence intervals and 19 degrees of freedom. And if I do that, where's that? So here, 99% confidence, 19 degrees of freedom. It's 2.861. So this part is just 2.861. So you don't have to put the plus or minus, but you can if you want. In the next part, find the standard error. The standard error in this case we have is the standard deviation divided by the square root of the sample size. And I give you both of those already. The sample standard deviation is 0.4. And the sample size is 20, so it's 0.4 over the square root of 20. And you can just leave it like that on the exam if you want. Then the next part, compute the margin of error. You can find that by taking the critical value times the corresponding standard error. So the standard error you found in this part and the critical value in this. So it'd be 2.861 times 0.4 divided by square root of 20. And that is how you find that part. Does that make sense so far, Kelly? Then the last part, give the 99% confidence interval. So that just means you take the sample mean X bar and you add and subtract the margin of error T alpha over 2 times S over the square root of N. So you're just taking the answer from part A and adding and subtracting the answer from part D. And that will give you 2.51 plus or minus 2.861 times 0.4 divided by the square root of 20. And that'll give you a confidence interval of, let's see, 2.254. And then find the upper limit, you just add the margin of error, and you get 2.766. You okay with that? Do you want me to write down the interpretation as well? Then the interpretation would be, we are %99 confident the population mean GPA of OSU students is between 2.254 and 2.766, and that would be the interpretation. Is there any other one you wanted to look at?
I have a question, but I don't really know how to type it.
What's up?
So it's a t-value when it's a sample, and then when is it a z?
Whenever you have the population. So if this would have said the population standard deviation of 0.4, then you would be looking at a critical Z value for 99% confidence. So this part would have changed, which in turn would have changed this part and this part.
Okay, that makes sense. Thank you.
You want me to show you how you would find the critical Z value in that case?
Yes, please.
Okay, so if this said population, then you want a 99% confidence interval. So say you have the distribution of the Z scores here. And you're going to have the area in between a positive and negative Z score. So let's say this is minus Z naught and this is positive Z naught. The area in the middle here is the confidence level as a decimal, so 0.99. Then that implies that the area in these two sections added together, these two tails, is 0.01. And since these are the same number of standard deviations away from the mean on both sides, that means the area in this tail is going to be the same as this one. So you can just look at the area in this tail. And it's 0.01 over 2, which is 0.005. And then you just look for a Z-score in the table with this area to the left. And if you do that, you'll find that minus Z naught is minus 2.58. And that would be the critical value for this part. So you could just point 2.58. So if I change this confidence level, this critical value will change from an instance. If you're doing a T, you'll just look at the thing and then intersect that new confidence level with the degrees of freedom. And if it's a Z, you'll have to do this same thing here. Just look at the area in the middle as the confidence level as a decimal, and then take half of the area remaining to the left, and then just look at that area in the table to find the critical value.
Okay, thank you. That makes a lot more sense.
Yeah, this part, that's the hardest part.
Yeah.
It'll get worse next chapter because you do this all the time. But in this next chapter, we talk about when you only have the area on one side instead of two sides. If y'all have anything else, just let me know. All right, Callie, see you tomorrow. Sage, is there any questions you had? All right, sounds good. There should be some people coming at 5:15 because I think they have a test that gets out at 5:15. All right, sounds good. If you have any other thing that comes to mind, just let me know. Gosh dang it, come on, phone.